Welcome to the session on computing the symmetric difference between two arrays. In many programming scenarios, we often need to find values that exist in one array but not in the other. This is especially useful when working with datasets, filtering records, or performing comparisons between different sources of information. Today, we will be learning how to achieve this using JavaScript's built-in methods, ensuring efficiency and readability. Let's get started. The symmetric difference refers to elements that exist in one array but not in the other. Unlike the intersection, which finds common elements, this approach finds the ones that are exclusive. For example, in the arrays 1, 2, 3 and 1, 2, 4, the elements 1 and 2 appear in both, but 3 and 4 are unique to each respective array. Our goal is to filter these out efficiently. This function follows a straightforward yet powerful approach. First, we convert both arrays into sets, which allows us to perform quick lookups. Then, we use the filter method on each array to keep only the values that do not exist in the other set. By concatenating the results, we get a symmetric difference. This method is not only concise, but also efficient, as set operations have an average time complexity of 1 for lookups. The function operates in 3 major steps. First, we transform both input array into sets, ensuring that elements are unique and enabling quick lookups. Then, we filter out elements that appear in both arrays by checking if they exist in the opposite set. Finally, we merge both filtered results to produce the final symmetric difference. This method ensures an efficient ON time complexity, making it highly scalable for large datasets. Let's break this down with some examples. In the first case, 1, 2, 3 and 1, 2, 4 share elements 1 and 2. The symmetric difference is 3, 4. Similarly, for 5, 6, 7 and 6, 7, 8, the unique elements are 5 and 8. This pattern holds for larger datasets, ensuring precise comparison between two arrays while filtering out common values. The ability to compute symmetric differences is useful in many practical scenarios. For example, in databases, we can compare two tables to identify records that exist in one but not the other. Similarly, in version control, we can determine which lines of code were added or removed between different versions of a file. This logic can also apply to inventory management, where we track which items were added or removed from the stock list. This concept has broad applications in data comparison, auditing, and debugging processes. In summary, the symmetric difference function provides a highly efficient way to compare arrays and extract unique elements. By leveraging JavaScript's set and filter methods, we can process even larger datasets with minimal performance overhead. Whether the database comparisons, version control, or user management, this approach offers a practical solution for identifying differences between two sets of information. Thank you for following along, and happy coding! Thank you for watching. If you enjoyed this video, please make sure to like and subscribe for more JavaScript tutorials. I'll see you in the next one.